Now we want to look at perfectly inelastic collisions. In a perfectly inelastic collision, two or more objects collide and then stick together, and they move as one after the collision. The case we are looking at, an apple is struck by an arrow, so after the collision, the arrow is inside the apple, so they are moving together with the same velocity. These problems are pretty tractable because the final momentum will be the mass of the two objects added together times the final velocity of the objects. So in these collisions, kinetic energy decreases after the collision, so we can't use kinetic energy to try and solve the problem. Momentum is conserved in these collisions, so we can solve the problem by finding the initial momentum of the system before the collision. We can then divide that initial momentum by the mass of the two objects added together to get the final velocity. Okay, so I've set up a pretty straightforward example here. An arrow with a mass of 1 kilogram travels with a velocity of 30 meters per second to the right, where it pierces an apple with a mass of 2 kilograms, which is initially at rest. After the collision, the arrow and the apple are stuck together. First, we want to know what is the initial momentum of the arrow and the apple. Finding the initial momentum is pretty straightforward. Our initial momentum is the mass of the apple times the velocity of the apple plus the mass of the arrow times the velocity of the arrow. So in this case, our arrow is moving and the apple is stationary, so the momentum of the apple is just 0. The momentum of the arrow is 1 kilogram times 30 meters per second, and so the initial momentum is 30 kilograms meters per second. Now we want to find the final velocity. Well, the velocity of the apple and the arrow are the same, so they are equal to each other. So the momentum after the collision is the mass of the arrow plus the mass of the apple times the final velocity. Due to conservation of momentum, the initial momentum is equal to the final momentum. So they are both 30 kilogram meters per second. So we set the initial momentum of 30 kilograms meters per second to be equal to the final momentum, and that is equal to the sum of the masses, so 1 kilogram plus 2 kilograms to give us 3 kilograms, times the final velocity. Now we just solve for the final velocity by dividing the momentum by 3, so 30 kilogram meters per second divided by 3 kilograms gets us our velocity of the combined arrow and apple to be 10 meters per second. If we wanted kinetic energy, we could then use 1/2 mv squared to find the kinetic energy of the arrow and apple, or, compare the initial or final. One problem that is particularly nice because it combines all the concepts we've done in the last 2 units is the ballistic pendulum. In a ballistic pendulum, a heavy weight is hanging from a support, and some object is fired into the weight. The idea is we would like to know the initial velocity of the projectile, and we determine it by measuring how high up the pendulum swings. There is a completely inelastic collision between the fired object and the pendulum. This time, we want to find the initial velocity, so the initial velocity times the mass of the projectile is equal to the momentum of the projectile and the pendulum after they have collided. So, using conservation of momentum, we find that the initial velocity to be equal to the sum of the two masses times the final velocity divided by the mass of the projectile. A little bit of algebra turns this into 1 plus the mass of the pendulum divided by the mass of the projectile times v is equal to the initial. Now we know how high the pendulum swings, so that means we know the potential energy in the pendulum, which is mgh, where we are using the mass of the pendulum plus the projectile. That potential energy will equal the kinetic energy after the collision. So if we set mgh equal to 1/2 mv squared, we get v is equal to the square root of 2 times g times h. So if we plug that in for v final, we get 1 plus the mass of the pendulum over the mass of the projectile times the square root of 2 times g times the height. That's the general form, so you can then find out how fast the projectile is motion. The key is that there are 2 steps. The first is to use conservation of momentum to find the velocity of the pendulum after it is collided with a projectile. Here, kinetic energy is not conserved, so we use momentum to find the velocity. Next, we use the velocity after the collision to find the kinetic energy. The kinetic energy after the collision is then converted into potential energy, so you can then find the height that the pendulum swings. Okay, so now it's your turn. So one of your problems here is pretty much the arrow and apple problem. It's the same, but it's got some different numbers on it. The other goes through the pendulum problem. In this case, you're given the initial masses and velocity of the projectile, and you find how high the pendulum swings. It's pretty much the same as the arrow and the apple problem. It's just that you then find the kinetic energy, and if you have kinetic energy, then you can find potential energy and the height. Good luck.